What up, peeps? Welcome back to another math vid. And today's topic is once again like sets of numbers, and you have to find out what all of these numbers have in common. So let's start. Question 1. Use the set of numbers shown to answer the question. So we have 1, 2, 3, 4, and 8. About to say 5. But what describes the set of numbers? Well, factors of 12, definitely not, because 8 is not a factor of 12. Prime numbers, no, 4 and 8 are not prime. Whole numbers, maybe. Composite numbers, no, 2, 3, and 1 are all not composite, so it has to be whole numbers. Whole numbers are basically like 0, 1, 2, 3, 4, and then so on. No negatives, though. Math vocabulary time. 2. Use a set of numbers shown to answer the question. Well, this is pretty easy. As you can see, all of these are in math vocabulary where it's described as mixed because it's like not a normal, like, complete fraction. It's not a irregular fraction, but it's also not a regular fraction. So it has to be mixed. It's pretty easy, this one is. I just talk like Yoda. Oh my god. All right, number 3. Use the set of numbers shown to answer the question. 6, 12, 24, 36, and 48, which describes the set of numbers. And what really caught my eye this time was the factors of 6, because only one number there is even like equal to 6. So I don't think it's definitely not factors of 6, actually, not just I don't think. Factors of 12. Well, there's two. But the rest are all bigger than 12, so it can't be the rest. It can't be B. Multiples of 6. Maybe. Multiples of 12. But then that would mean that 6 was not there, so that means D is not it. So it has to be C because... And if you're in like practice, you can check like 6 times 1 equals 6, 2 times 6 equals 12, 3 times 6 equals... 4 times 6 equals 24, 6 times 6 equals 36, and 8 times 6 equals 48. So, yes, they are all factors. They're all multiples of 6. Easy. Use the set of numbers shown to answer the question. 3, 5, 7, 9, 11, and 13. All right, which describes this set of numbers? And just like a bit of an explanation on what consecutive odd numbers are, they're extremely specific. They're basically just all odd numbers, and each time they have to add 2, which is surprisingly specific. Yeah, it's definitely not irrational numbers. Irrational numbers are numbers like pi that go on forever and ever and ever and ever. And then there's prime numbers. Well, no, because 9 is not prime. And factors of 1, that's even worse. That's like, I don't even know. There's not even a 1 in there. So it has to be consecutive odd numbers. Consecutive odd numbers, like I explained, it's extremely specific. It's like, let's give an example here. Like, let's say... like 3, 5, and 7. It's basically plus 2 every time, and they have to be odd. So, so it is consecutive odd numbers, because 3 plus 2 equals 5, 5 plus 2 equals 7, 7 plus 2 equals 9, and so on. And yeah, that's the end of this vid, and I hope you guys enjoyed, and I hope it helped. And I guess I'll see you guys in the next one. Bye!